Welcome students. We come back again with a new video again. My name is Suman Upadhyay and you are watching my channel Suman Sir Classes. Okay, let's start our today's video. Okay, in this video we discuss the following topics. Which topics? Let's see. First one, that is the electric flux. This one, okay? And after that we discuss about the electric flux, its dimension, its SI units, and what is the meaning of the electric flux. What is flux? I don't know. You know it? No, you don't know it. So we discuss about this in these parts, and also we discuss about the Gauss's theorems. Okay, Gauss's theorems. So you forgot about it? Okay, no problem at all. Let's see what is electric flux. First, starting with that. Okay, so let's see the first things, that is the electric flux. The first what? You just think about that. Flux. What is flux? First question arises in your mind. What is flux? What is the importance of this in the physics? So flux is the meaning. Okay, what is the flux meaning? Consider the water can flow in the forward directions. It may be water or any type of fluids. When the fluids flowing in the following directions, that means when we placed a window just like that, this one, okay, so a window is placed over there, so certain quantity of water can easily passes within the window. This is occur. This flow of liquids, this flow of fluids is called the flux. So flux can be specified as the flow of fluids. Now it is clear. So that means flux can be associated with the terms that is the flowing of fluids. That's why it is called the flux. I think now it is clear. So now I just give you some simple considerations. Consider today we discuss about the electric flux. This one is the electric field. Okay, number of electric fields are passes together. In my last video we discussed about the electric dipole. In this video we just discuss about when the uniform electric field is just acted in this case. Just see that number of electric field passes and their value, it is constant. This one E, this one E, this one E, all these terms are E. If I place a plate just perpendicular over there, okay, so number of electric field lines passes within this window. Just consider here only with a small window, so therefore only 2 electric lines passes. Same thing here, that is the larger window, so therefore 1, 2, 3 electric lines passes. Understood what there? Okay, let's see. So consider this one. This one is the one window. You consider, okay, 3 electric field lines. This one is 1, 2 and 3. Okay, so 3 electric field lines easily passes over there. These are the parallel, so these easily passes over there. This is very easy. Okay, passes over there. But if I take a larger electric field lines, that is the larger area over there. Now here 4 electric field lines can be easily passes. Just check it out. 4 electric field lines can easily passes. More than 4 electric field lines are passes over there. So that means when the area increases, larger area, larger number of electric field lines passes. Okay, so you can take the smaller area, this one larger area, so larger number of electric field lines passes. Same thing if you take the smaller area. Here it is the smaller area, so small number of electric field lines passes. So electric field lines passes within the area. It is depend on the number of, that is the area of the surface. If area increases, more electric field lines passes, because the surface, the area is uniform electric field. Okay, so this is the main considerations. So from these considerations we can say that the area is the one of the factor. More area, therefore the more number of electric field lines passes. Okay, now it is clear. Now here we consider the elementary surface. This one. Why it is elementary? There is no shape. That's why we consider the elementary surface. This surface is produced with a number of smaller surface. Just consider this one. This one is the smaller, this one is the smaller. In this way, number of smaller surface can produce the this total surface, total elementary area. Okay, total elementary body of this case. Now, in this case, just we consider the first area. This one. The area, this area is surface area is ds. That means total body can be divided into a number of smaller parts. That is number of smaller area. So each of the area is ds. So this one is ds. this one is ds, this one is ds in this way. So number of area, that is all the elementary area, is ds. Okay, so directions of the each of the area. What is the directions of the each of the area? Now the questions arises. Area is a vector quantity. If I consider this one is area, just like that, just check it out. You know it from class 11 concept. We just recapitulate this part. I think it is very much easy for you. So just consider this is the rectangle. Okay, so rectangle, this one is x-axis, this one is y-axis, this one is z-axis. So this one is considered A and this one is considered B. Okay, so A and B, this is the total area. So what is the area in this case? This one is vectored and this one is also vectored. So total area, that is capital A, obviously vector A cross vector B. Okay, so this one is the cross product of the two vector always gives the vector value. So that's why area is a vector. Now a question arises in your mind, sir, what is the directions of the area vector? Obviously, consider vector A. Vector A acting in which directions? X-axis. So what is the unit vector along x-axis? That is equals to I cap. Okay, so vector B, it is acted along the y-axis. So in this case, the vector unit vector is j cap. So next one, that is the area vector. Now I cross j cap. So what is the cross product of this? So I know that according to the I cross j, that is equals to k cap. That is I cross j, that is, it means I acted in the perpendicular direction, that is along the k cap. So area vector has some direction is k cap. That is for a plane. The area vector directed perpendicular direction, that is along the k cap of it. Okay, so that means area vector always perpendicular to the surface. So in this case A and B, this is the plane in the xy plane. So area vector directed perpendicular, that is in the outward direction. So area is a vector. It is acted always the perpendicular directions. Now it is clear. Okay, let's see now. So this first area, number one, consider the area is ds. So ds area acting which directions? Perpendicular direction. Okay, so this ds area makes some angle theta with the electric field E, because the body is placed in the uniform electric field. So that means here the angle is theta. Okay, so this theta represents the angle between the area and the electric field. So what is the phi? That is, what is the flux? What I say, that is total number of electric field lines passes within the area. The simple considerations you consider. So phi equals to phi, that is the symbol of the electric flux. Okay, this one phi. So phi equals to E dot ds. Why E dot ds? So that means electric field acted, consider unit for ds area, E electric field acted for unit area. So ds area, this electric field acted in this case, that is equals to E dot ds. Okay, now it is clear. ds area, okay, total area ds. So for E area, consider, so E dot ds represent the total electric field. Okay, just check it out in this case. E dot ds, this is the dot product. Dot product means that is the scalar product. For these reasons, the number of cases the questions arises, what is the quantity? That is the flux phi. Is it scalar or vector quantity? So obviously this is the scalar quantity, because this is the dot product or scalar product. So E dot ds, what is the ds? ds is the small area, small elementary area of the particles. Okay, so here number of particles is present. So if I take all the elementary body, so we just integrate over the surface. Okay, now it is clear. So just we integrate the value over the surface, that is E dot ds. So E dot ds, just simple explanations. Now we consider ds. ds is the area. Area is a vector. So ds vector, it can be written in the form that is ds into n cap. Am I right? Because n cap is a unit vector and the direction of the n cap obviously perpendicular to the surface. Clear? So ds into n cap, this one is represent the ds. So it may be written in the form, just check it out. So phi equals to surface integral is E dot n cap ds. Okay, so E dot n cap ds. Now E dot n cap, so can you tell me dot product of A and B? Dot product of A and B, yes, A B cos theta. Okay, when it is cos product, maybe sin theta, it may be sin theta, that you know. So E dot n, it may be written in the form that is E cos theta. And n cap, what is n cap? Mod value of E, mod value of n cap. N cap, that means unit vector. So mod value of n cap, obviously 1. So it may be replaced with the 1. So maybe the value is E cos theta. Okay. So let's check it out again. So this one S, that is equals to E ds cos theta. So this is the value. So E ds cos theta, this is the value. Now in this case, E does not depend on the surface, cos theta does not depend on the surface, only depend in the surface of the area, that is equals to ds. So it may be, that is the ds over the surface. If I know the formula, if I know the shape of the body, it may be some geometrical shape, obviously in this case. So that's why when we just place the value of ds, okay, if I know the value of ds, we can easily calculate the value of flux. Okay. So in this way, we just calculate the value of flux very easily. Now a question arises, sir, how many types of flux is present in this area? So flux can be categorized into the 3 categories. First one, positive flux, negative flux, and another one, the zero flux. Just check it out for the first case. First case, theta, this one, theta is the angle. Okay, now just check it out here. Theta is the angle, obviously theta less than 90 degree. Here theta equals to theta less than 90 degree. Now tell me cos 0 degree, that is equals to 1. So cos less than 90 degree, obviously it gives the positive value. Okay, so that means cos theta in this case, when theta less than 90 degree, then cos theta obviously that is equals to, gives the value of positive. Clear? So that means when it is the positive, so we just replace over there. So when cos theta is positive, then it gives the value of flux. That means the flux phi is positive flux. Clear? Now in the second case, when theta equals to 90 degree, just check it out. Okay, this is the perpendicular direction, this one. So here what is the angle between theta? That is theta equals to 90 degree. So what is the value of cos 90? Yes, there is 0. So it may be written in the form that is theta equals to 90 degree. That means cos 90, that is equals to 0. So in this case, for the second case, the phi can be represented in the form that is zero flux or null flux. And the last one, so here it is the angle theta, that is equals to greater than 190 degree, greater than 90 degree, that is it may be represented in the forms that is greater than 90 degree. When greater than 90 degree, 90 degree is 0. So greater than 90 degree, so cos value obviously represented in the forms that is negative sign. So that is in this case cos theta is less than 0. So that is phi is negative in this case, that is negative flux. Absolutely right. So that means 3 value we just calculated over there, theta less than 90 degree and all these cases. Okay, so in this way we can find out easily the flux is positive, negative or zero flux. Now I think it is considered, it is clear to all. So E dot ds, if I know the value, that is E cos theta, and integrate over the surface of ds, we can easily calculate the value of the flux in this case. Okay, so it may be written in the form that is over the surface ds. So it is written in the form that is E ds cos theta. So this is the value. Okay, so if I know the other value, that is E ds and other all, so we can easily calculate the value of flux. Okay, now flux, up to this flux is considered, flux concept of flux, it is clear. Now we next move to the part that is the dimension and the SI unit of the flux. Let's see dimension of the flux. So first one, F equals to E into ds. Just we write here E ds cos theta, that is equals to E ds, E dot ds. So what is E? That is the electric field. Electric field equals to, it may be written in the forms that is force by charge. So that means force by charge. And what is ds? ds is the area. So it will be written in the form that is equals to area. Okay. So now if I want to find out the SI unit, what is the SI unit of the force? Force SI unit is, tell me, that is the Newton. Okay. So charge SI unit, that is the Coulomb. and area SI unit is meter square. So it may be written in the form Newton meter square Coulomb to the power minus 1. So this is the SI unit in this case. Okay, now check it out. That is the dimension, the next part of this. So phi can be written in the forms phi equals to force by charge into area. Okay, so force by charge into area. So what is force? Force written in the forms. Okay, what is force? Dimension mLt to the power minus 2. What is C? That is the charge dimension 80. And the next one, that is the area. Area represented with the form that is L square. So this one, so it may be written in the form that is equals to m L cube t to the power minus 3 into a to the power minus 1. Okay, this is m1 L square into 1, that is L cube t to the power minus 3 and a to the power minus 1. So this is the dimension of flux. Okay, so up to this flux is complete. Now we move to the Gauss's theorems. Okay, next we move to the other cases also. So next part, that is the Gauss law. It's called Gauss theorems. Okay, let's see. So this one, the importance part, the maximum numericals problem related to the electric flux appear from the Gauss law. So now questions arise, sir, what is Gauss law? What is the Gaussian surface? So these are the part you have to remember in this case. So first one, simple explanations of this. Okay, so we just repeat once again. The charge Q, consider it may be plus, it may be minus. So Q charge is placed at the center point O in this case. Okay, so this one, all the electric field are acting in the outward directions. Clear? Okay, so all the charge can be written in these forms and it is acted in the outward directions. Okay, so this surface, over the surface, it is represented as a Gaussian surface. Now within this Gaussian surface, if I consider number of elementary area present over there, okay, within this surface, the total flux linked with the surface, because number of electric field lines emitted. Okay, so here we consider the small area, number of small area are added together. Okay, so all the number of area is added together, number of field lines passes within each of this area. In one area, 2 or more than electric field lines passes. So that means electric flux can be generated in each of this part. Electric flux can be calculated in each of this small area. So when we summing up all the flux throughout the surface, then we can get the total flux. So E dot n cap ds, this is the flux. E dot n cap ds, it is the flux. For which area? Consider this is the small area, first one. Okay, so in this way, anyway, number of ds, all the number of area are added together, produce the surface, spherical surface or other type of surface. So that means when we summing up all the surface, we can get the total flux. This summing up all the flux can be represented, can be calculated by the integration of this. So integrations occur in this case over the surface. Okay, so Gauss law, Gauss theorem stated as, so surface integral E dot n cap ds, that is the total flux related to this surface, that is equals to the total charge within the surface divided by free space permittivity, that is epsilon naught. Okay, so if I know the value of total flux, so it is represent flux means obviously denoted with the phi. So phi equals to surface integral E dot n cap ds, that is equals to Q by epsilon naught. So in this way we can easily calculate it. If I know the other part of this, total flux equals to Q by epsilon naught. If I know the value of Q and epsilon naught, so we can easily calculate the value of flux. Okay, so this is the Gaussian surface or Gauss theorems. Okay, next we move to the forms, that is representation of the Coulomb's law from the Gauss theorems or the Gauss law. Let's see what happens. Okay, so the next one, derivation of Coulomb's law from Gauss law or Gauss theorems. Let's see. Consider this is the surface. Okay, last we discuss about the Gauss law. So there is one, this is the surface. The charge placed at the center. Consider the center point is O. At the center point O, we place a charge, that is the plus Q charge. Okay. So from the plus Q charge, electric field emitted in the different directions. So one electric field, consider the directly along this direction, that is along the E. Okay. We just repeat again. At the center point O, we place a charge plus Q. Due to this charge, the electric field lines emitted throughout the surface, throughout the Gaussian surface. Okay. So this electric field acting, consider one of the electric field is acting along the directions. Okay. So on the point, on the electric field lines, we consider a fixed point P. Here it is. This is the fixed point P. We just want to find out the electric flux at the point P at first. After that, we just again integrate full of the full surface and we just find out the total electric flux. Okay. So now consider at the point P, the small area is present. This area is ds. Okay. So flux in this case, we can write in this form, that is phi E, that is equals to E dot ds. This one. So total flux, because in this way number of small surfaces, that is the area ds, are placed over this. So we can integrate over there to get the total flux. So total flux phi E, that is equals to integration of E dot ds. This one. Okay. So now E is constant, does not depend on the surface area. So just write here integration of ds here. Okay. So here integration of ds. So here occurred in this case. Now what is ds? If I consider this one is the sphere. Okay. Gaussian surface is sphere. So obviously if I integrate ds over the surface, that means over the surface of the sphere. So over the surface of the sphere, ds equals to what is the area of the sphere? That is 4 pi r square, because radius of the sphere in this case, that is equals to r. So 4 pi r square, just putting the value here. So that is equals to E into 4 pi r square. Consider this is the equations 1. Okay. Now according to the Gauss theorems or Gauss law, we can write here, that is E into 4 pi r square, that is equals to Q by epsilon naught, because this is the total flux phi, that is equals to E 4 pi r square, that is equals to Q by epsilon naught. So we just write here, so E equal 1 by 4 pi r square Q by epsilon naught. So this one is the value. This is the electric flux linked with a small surface, that is equals to ds. Here it is the over the surface area, over the sphere. Okay. So total electric field, this one. Now we consider at the positions ds, at the positions P, a small area, that is the ds. Within this ds, we just place a test charge. This test charge is placed, that is equals to Q0. Okay. So if the Q0 is present at the positions P, in which electric field? In the electric field of E. Okay. So that means we can write here, that is total force acting on the test charge. Test charge placed at the positions P. Okay. In the electric field E. So that means total force acting in this case, that is equals to Q0 into E. Okay. So now here the equations 2, from equations 2 just putting the value of E here. So we just write 1 by 4 pi epsilon naught Q into Q0 by r square. This is the value of force. Now just check it out. 1 by 4 pi epsilon naught Q into Q0 by r square. This is the Coulomb's law. This is the Coulomb's law. So by the using of the Gauss's theorems, we can easily calculate the Coulomb's law. Okay. So in this way, we can calculate the value of the Coulomb's law from the Gauss's law. So today we discuss the following parts. Okay, that is the flux, number of types of flux, and the derivations of this, and also that is the dimensions, SI unit, Gauss law, and the next one, that is the Coulomb's law, for derivations of the Coulomb's law, representations of the Coulomb's law from the Gauss theorems. In my next video, I will discuss the potential, that is the electrostatic potential, and their different cases. Okay, so definitely watch my video positively, and obviously take out your pen and also every day, each and every day, write all the parts. Okay, and the numericals also, this is very much important. So write all this part, do your work positively. Okay, this is one time, this is the biggest time for you, so do it. Okay, so thank you everyone, keep watching my channel and subscribe my channel. Thank you.